So here we go. Chapter 7, Section 1. Which is Introduction to Sign Numbers. Almost so far, I think, I'm almost positive, everything we did was with positive numbers only. Now you are going to be seeing positive and negative numbers, both. So you're going to see some numbers above 0, some numbers below 0, negative values. When they say the temperature is 20 degrees below 0, what does that mean? Minus 20 degrees. Temperature today is 52 above 0. That's what? Plus 52. If you go to park your car in a garage and you go to, it's one of those garages where you have to go under the ground and you park, so you park your car, third level below the ground, below the ground level. So you park where? You actually negative 3 below. You are negative 3 from the ground, down there. If you park on the 6th level or the 7th level, you are above the ground. So we're going to be dealing with positive and negative numbers. When we look at the number line, if you remember that number line.
Yes, sir, Dad.
Yes.
I have a question. How can we find sign numbers? Because I learned them as integers.
Well, they don't have to be just integers. Integers could be positive and negative. What about if it's like temperature? Could be negative 3.1. Because once it's not a whole number, it could be decimal value. Some integers are actually 5, 7, 6, 9. Those are integers. You're right. They could be plus or minus. But if it has a decimal to it, 3.1, 3.2, 2.5, those are not integers, real numbers. Yeah. So you're welcome. So we're dealing with all numbers, not just whole numbers. We're going to start with whole numbers. We're going to add fractions to them. We're going to add decimal values, repeating, non-repeating, and so forth. So the number line, this is 0. To the right of that is the positive numbers. Again, what I'm writing down, these numbers are the integer values. When you include what's in between them, that's the number line, the real numbers. Minus 1, minus 2, minus 3, minus 4, minus 5. Again, positive. Those numbers are what? Negative. What about the 0? Is it positive or negative?
Neutral?
Exactly, neither. Yep. It's not a positive number nor a negative number. Now, if we just look at the whole numbers here, these are called positive integers. If we look at the minus 1, minus 2, minus 3, minus 4, minus 5, called negative integers. But if we start including like 1.1, 2.2, then these are positive real numbers. Negative 1.5, negative 2.7, negative 3.3, those are negative real numbers once you put in decimal values to them. So if we ask you on the number line, let's locate some of these numbers. On the number line, I want you to locate where the 1/2 is, where the negative 2.8 is, where the 1/8 is, where the negative 3.1 is. Let's see where they align. This is the number line. I'll make them big. 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Where's the 1/2? Halfway between 0 and 1. There's the 1/2. Where's the negative 2.8? Closer to negative 3, right? Negative 2.8 here. Let me make that, because I don't have room to write it there. It will be, well, I could squeeze it there. Okay, where's the 1/8 goes? Yep, somewhere here. This is the 1/8. If you take between 0 and 8, 0 and 1, cut it to 8 places, in the first slot, that's where you put it. Where's the negative 3.1? Somewhere here. So the positive number is always to the right of 0. The negative number is always to the left of 0. Let's look at the definition of opposite numbers. Opposites. Definition for that's really like two numbers that are the same distance from 0, but that's not the only thing. From 0, so on the number line, let's be specific. But, that's the definition, but that's the big but. But what? On opposite side. On opposite sides of 0. That's the definition of opposite. Two numbers. This is the 0. This is the 1. This is the 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Notice the minus 1 and 1 are opposite to each other. Why? They both have the same distance from the origin and they land on opposite side. Minus 2 and 2 are opposite to each other. The same distance from the origin from 0, but on opposite side of the 0. The 3 and the minus 3 are opposite. So if I give you a number here and I ask you for the opposite, let's think about it. What is the opposite of 4? Negative 4. That's right. 4 and minus 4 have the same distance from the 0 on the opposite side. What is the opposite of negative 3? Positive 3. What's the opposite of 5? Negative 5. What's the opposite of negative 7.2? Positive 7.2. What's the opposite of 1/3? Negative 1/3. So to find the opposite, we just change the sign. Because the definition says two numbers that are the same distance from 0 on the number line, but on opposite sides of 0. The only ones will be these numbers. 5, we have negative 5. Negative 7.2 has to be 7.2. The 1/3 has to be the negative 1/3. We just change the sign of a number. So that's what the opposite is, change the sign of that number. You'll see that when we get to adding fractions or adding numbers, sign numbers, not fractions. It could be fractions, but it doesn't have to be. But that's what opposite means. Another term you'll see here in this section or in this chapter is called the absolute value. The absolute value. The absolute value of a number is the distance, that's the definition, is the distance from 0 on the number line So the absolute value of a number, I should make it, is instead of the distance, I should say it's its distance. Probably be a better definition. It's its distance. That number distance, the distance between the number. So instead of that, maybe, otherwise, like I said, the distance from 0 to the number. How about say its distance? I like the word its. Distance from 0. How far that number from 0. And we use these straight lines up and down for absolute value. And distance will always be positive. Distance will never be negative. Why? You can't say I ran negative 4 miles today. Even if you run backward, you still ran 4 miles. There's no such thing as negative distance. So what is the absolute value of negative 2? How far that number, the minus 2, from 0? Isn't it 2? What's that distance? 2. What's the absolute value of 5? Now here's the 5. How far that number from 0? 5. What's the absolute value of negative 4?
4.
How far the negative 4 from 0? 4. What's the absolute value of 3? What's the absolute value of 0? 0. What do you notice about that? The absolute value. When the number is positive, what do? Leave it alone. When the number is negative, what do? Change it to positive. If you look at the definition for it in the math book, I don't see it in our book, which said the absolute value of x is x if x is greater than or equal to 0. If the number is bigger than 0 or equal to 0, leave it alone. That's what that says. But if the number is less than 0, what do you want to do? Take the opposite of that. That's not minus. That means the opposite of that number. And what's the opposite of a negative number? Positive number. So the absolute value, always positive. Will never be negative. Always positive. So if the number is positive, leave it alone. If the number is negative, change it to positive. Simple as that. Let's give you a few problems to try on absolute value. Ready for that? What's the absolute value of 9? 9, good. What's the absolute value of 1 2/3? If the number is positive, leave it alone. If it's negative, change the sign. What's the absolute value of negative 4.1? 4.1. What's the absolute value of negative 5? 5. Here we go. Ready for this? The minus outside, the absolute value of negative 3. Try again.
I think negative get cancelled.
Nope. Why negative 3?
There's a negative outside.
Here's the minus sitting outside. What's the absolute value of negative 3?
30.
3. You can't distribute that like we did with parentheses. You can't do that. So it's a negative 3. So if you have a minus outside, can't touch it. It's still sitting outside. The absolute value itself cannot be negative. The absolute value of negative 3 is 3, and that minus sign is still sitting in the front. And the next thing is we need to figure out, how do you tell when you look at a number which one is bigger, which one is smaller? Comparing numbers. When I give you a stack of numbers, tell me which one's bigger. Comparing numbers. Here goes the number line again. 0, 1, 2, 3, 4, 5. Negative 1. Negative 2, negative 3, negative 4, negative 5. If I write 0 and negative 2 and you compare them, you tell me which one's bigger, which one's smaller. The number on the right always bigger than the number on the left. Where's the 0, where's the minus 2? Which one on the right? Is always bigger than the number on the left when you're looking at the number line.
So 0 is bigger.
0 is bigger. This is bigger, greater than. In case you forgot, greater than. Less than. We use the other one. So 0 is greater than negative 2. 5 and 4. 5 is greater than 4. Negative 5 and negative 3.
Negative 3 is greater than.
So negative 5 is less than negative 3. Or negative 3 is bigger than negative 5. Remember, the number on the left is always smaller than the number on the right, or the one on the right is always bigger than the one on the right. The negative 5 is on the left, it's smaller than negative 3. The minus 2 and the 1. One is what? Greater. So the minus 2 is smaller, or the 1 is bigger. So you have to write the minus 2 is smaller than or less than the 1. 0 and negative 4. 0 is bigger than. 0 on the right, negative 4 on the left. The number on the right is larger, the number on the left is smaller. So 0 is bigger than negative 4. I'll throw another one. 1 1/5. And the other one, minus 11.5.
Greater than.
Are you sure?
Yeah.
Why?
1 and 1/5 is positive.
Exactly. 1 and 1/5 is a positive number. It's on the right side. Somewhere here. And where's the negative 11? Way down here on the left. So 1 and 1/5, a positive number is always bigger than a negative number. Always. Doesn't matter what the value of that. I could have given you 0.0001, and on this side, negative 1,000,000. The 0.0001 right after the zero, somewhere right here, next to the zero. And where's the negative 1,000,000? Keep walking all the way to the left. So which one's bigger? That number. People struggle with negative numbers. How can this number be bigger than that? The number on the right is always bigger than the number on the left. Doesn't matter how small, how big. The value of them, the absolute value. Okay. That's section 7.1.